Uh, Good morning and welcome to the class that is sponsored by the Center for the Humanities and the Public Sphere, which is entitled Echoes of the Past, Visions of the Future. And so the Center for the Humanities and the Public Sphere is a dynamic hub within the College of Liberal Arts and Sciences at the University of Florida, dedicated to advancing interdisciplinary collaboration, scholarship, and community engagement through the humanities. Through specialized programs, events, fundings, opportunities, and partnerships, the center aims to explore fundamental questions of human existence, inspire civic and moral responsibility, foster global and comparative understanding, and illuminate the role of the humanities in addressing contemporary challenges. CHIP celebrates the boundless curiosity that defines what it means to be human. Jamie Alberg is the Rothman Chair and Director, Center for the Humanities and the Public Sphere. As Associate Professor of Philosophy, she teaches both undergraduate and graduate courses in political and moral philosophy, and she supervises graduate students working in normative and applied ethics. Her research explores how ideals like equality and fairness come to bear on everyday policy and practice, especially in education. She served as president of the Association for the Philosophy of Education and maintains an affiliation with UF's Education Policy Research Center. Professor Alberg will introduce the course, Echoes of the Past, Visions of the Future, as well as our first speaker, Chris Dorst, who will present virtually on a new name for his presentation, Why Are the Laws of Nature So Useful? Professor Alberg?
Thank you, Rick. Thanks everyone for being here. Thanks also for that introduction of the Humanities Center. We do have three interrelated aims as a center that I think come together so nicely in this series, supporting humanities scholarship, providing space for interdisciplinary conversation and collaboration, and also engaging with the community within which the humanistic scholars live and teach. So we really appreciate this series. We appreciate being here. And thank you everyone for coming today. This series this year, Echoes of the Past, Visions of the Future, is going to feature talks by faculty who have won Rothman Fellowships from the Center for the Humanities and the Public Sphere for their excellent work and scholarship. So I want to thank also the Margaret and Robert Rothman Fund for sponsoring them, as well as the center as a whole. I also want to give a brief shout out to our website and encourage you to check out our programming because so many of the events that we put on are open to the public. So please check us out, humanities.ufl.edu. We offer lectures. We collaborate with various community organizations like the Links and the Hippodrome. We have programming throughout the academic year in particular, less so in the summer, but we're here now. So please check that out. Again, it's humanities.ufl.edu. So for this series in particular, we were thinking it's 2025. Hi, Ophelia. And, we were wondering, how did we get here at this moment in time? So the growing availability of historical data and diverse perspectives invites us to look at the past as a means of understanding where we are now, but also the possibilities for our future. And that becomes a really complex task as we recognize how connected and integrated we are in this global context. It prompts questions such as, what trajectory are we on? How do we access the global forces and assess them that shape our lives, what key narratives are missing in our conversations, and how can we make decisions that respect human experiences while acknowledging what is within our control. So this series invites all of you and our speakers to engage with those questions and challenges through a series of presentations that highlight how science, history, culture, and political movements inform our understanding of the present, but also guide us forward into the next moment. So this summer, we have talks by scholars from varied disciplines, including art, history, anthropology, Latin American studies, and philosophy. Next week, Dr. Portia Moore will explore the complexities of art repatriation to Africa and its ties to colonial history, offering insights into how historical injustices continue to reverberate in contemporary cultural politics. In a similar vein, the following week, Dr. Richard Kernahan will examine the relationship between the physical landscapes and political borders of South America, revealing how these spaces shape and are shaped by legal and social systems. We were then to have a talk by Dr. Stacy Liu, but I'm sorry to report that she has a serious issue that has caused her to go on leave at the moment, so she won't be able to give her talk. So please make a note of that. And then lastly, Carmen Martinez Novo explores the personal to the collective, illustrating how their pursuit of a family history story led to broader research on the Spanish Civil War, fascism, and democratic memory movements. And today, we begin the series with Dr. Chris Dorst, who asks how philosophy from the Enlightenment can inform and expand our understanding of modern physics, bridging the gap between historical thought and contemporary science. I'm very pleased to introduce Professor Dorst, my friend and colleague from the UF Philosophy Department. He's been associate professor and joined the department in 2019. He specializes in philosophy of science, along with some overlapping areas in metaphysics and the philosophy of physics. He's interested in questions about the metaphysics of physical laws, so you'll get some of that today, the nature and the direction of time, and the interpretation of quantum mechanics. He also has interests in later Wittgenstein and Proust, so you can ask him about those things in Q&A. That would be fun. So please join me in welcoming him today for his talk.
All right, thank you so much. Can you all hear me? All right, let me know if you cannot hear me at some point if the audio cuts out. But thank you so much, Jamie, for that very gracious introduction. I also just want to thank the Center for Humanities in the Public Sphere for the research funding last summer, out of which this talk is kind of a growth. And thank you all just for having me and for being here to listen to me talk for a bit and hopefully help me think through some of these issues. I do have to apologize. Let me share my screen now. The title of my talk is not what I advertised it was going to be. So it is slightly different. It's Why Are the Laws of Nature So Useful? I think the title that was advertised was about the Enlightenment and what it can teach us about physics. So if you came expecting a historical talk, I am going to have to disappoint you because I do not know much history, and I'm certainly not worth listening to talk about history. But in some ways, I will try to make good on the advertised title of this talk because I'm going to be focused on the idea of a law of nature, which is an idea that arguably took off with Isaac Newton's Principia, which was maybe a sort of pre-Enlightenment work. And certainly the idea of a law of nature kind of blossomed during the Enlightenment. And I'm going to be arguing that thinking carefully about this concept of a law of nature can give us an interesting and I think insightful understanding of what the physical enterprise itself is trying to do. So that's the sort of grandiose conclusion that I will I will hopefully make good on, or at least get close to making good on by the end of this talk. I also want to just mention that this work here is, at least in part, some joint work with Christian Loh at Umeå University in Sweden and Siegfried Jag at University of Cologne in Germany. Okay, good. So let's get into it. So one of the central tasks of physics is, of course, to answer the question, what are the laws of nature? Depending on which physical theory or which physicists you ask that question to, you'll get different answers. So in Newtonian mechanics, you would get the answer that, well, the laws of nature are, for example, F equals ma, that every action has an equal and opposite reaction, et cetera, et cetera. If you looked at quantum mechanics, you would get maybe the Schrodinger equation and maybe the measurement postulate as the fundamental laws of nature. And other physical theories would give you different answers. There are some commonalities to the answers that you would get from almost all physical theories that physicists have taken seriously, and I'll get to those commonalities a bit later in this talk. But that is, again, one of the central tasks of physics. We want to answer, or physicists want to answer that question, what are the laws of nature? I'm not a physicist, so I'm sort of happy to let physicists try to answer that question themselves. I, at least sometimes, think of myself as a metaphysician, a metaphysicist maybe, and it is one of the central tasks of metaphysics to answer the question, what are laws of nature? So you're just dropping the article there, the definite article there, and suddenly when you do that, the possible answers to that question change wildly, right? So instead of asking what are the laws of nature, we're asking what are laws of nature? That is, what kinds of things are these laws of nature that we're trying to discover when we do physics? In the literature on the metaphysics of laws of nature, there are a variety of different answers to this question. The two main answers, the ones that will sort of show up in this talk most today, are what we call Humeanism and non-Humeanism. So Humeanism is one of the answers, right? And that's so called because it is kind of loosely inspired by the philosophy of David Hume, though, of course, there are many Hume scholars who would be quite perturbed that contemporary Humeans about laws of nature call themselves Humeans. They don't think Hume thought anything like this. But regardless of whether that's historically accurate, it has, that label has stuck. So Humeanism about laws of nature is the idea that the laws are essentially just certain sorts of patterns in the events comprising the entire space-time manifold. So the space-time manifold being just the distribution of all the particular events that happen throughout all of space and time in the entire universe. And if you looked at all those from a sort of God's eye perspective, you zoomed out, the laws would be some sort of patterns in that space-time manifold. That's the Humean answer. It's kind of a deflationary answer. At least that's the intention of a lot of Humeans. And to see why it's deflationary, you might contrast it with a non-Humean answer. Non-Humeanism is it's a group of views that sort of have this one thing in common, but a lot of other things not in common. But the one thing they do have in common is they think that the laws are something that produces or governs the events comprising the space-time manifold, right? So they're not just the patterns in the space-time manifold. There's something that's kind of, you might say, behind the scenes, behind the space-time manifold, if I can use that sort of figurative terminology, governing it or producing it or constraining it to be the way that it is. So those are the two main answers, again, to the question of what a law of nature is or what the laws of nature are in the literature on the metaphysics of laws. And again, those aren't the only answers, but they are probably the two most popular ones. If I had to guess, I think probably non-Humeanism, some form of non-Humeanism, is the the more intuitive answer. It's certainly what I thought was initially a lot more intuitive when I first started thinking about this question. Though I have to say I've really done an about face, and I'm now pretty staunch Humean. So what I'm going to do in this talk is kind of give you an argument, in some sense at least, for Humeanism. But it's going to be an argument for a particular version of Humeanism that, for one thing, not all Humeans would agree with. But I do think it's going to lend itself to a sort of general and pretty interesting perspective on the enterprise of physics as a whole. That is, like, what its point is, what it's aiming at, and so on. So hopefully we can get to that by the end of the talk. Okay, so I just asserted, and hopefully you agreed, that it is one of the central tasks of physics to discover the laws of nature. But now I'm going to ask a couple questions to sort of kick things off. So why is it one of the central tasks of physics to discover the laws of nature? It's not one of the central tasks of physics to discover how many grains of sand are on the Cape Cod National Seashore, right? So what is it about the laws of nature that makes them worthy of our physical inquiry, worthy of being such a central target of physical inquiry? There are, roughly speaking, two potential kinds of answers that you might be inclined to give here. Maybe there are more, but these are the two that occur to me most readily. The first is that you might say it's just a matter of curiosity, right? So physicists are humans. They are naturally curious creatures, and the laws of nature seem like a natural thing to be curious about. So that's why it's one of the central tasks of physics to discover the laws of nature. They're just inherently interesting things, and we're interested creatures. I think that's a fine answer. I don't think it's the only possible answer you might give, but I think it's a fine answer. I think it is an answer that maybe coheres better with a non-Humean view of laws, right? So if you're a non-Humean, again, you think that the laws are something kind of behind the scenes, generating or producing or governing all the stuff that we see and interact with on a daily basis. So if you have that kind of view of laws, it's going to be fairly natural to think of them as these inherently kind of interesting things, right? They're hidden, but they're producing and governing everything that we have any access to, right? Those are worth inquiring into, worth figuring out what they are. So that's one answer. That's the curiosity answer to why it's one of the central tasks of physics to discover the laws of nature. Another potential answer, which is the one that I'm going to pursue in this talk, is that it's something to do with the practical utility of the laws. And in particular, in discovering the laws, we gain some sort of practical utility that is helpful to us and the kinds of creatures that we are. I also don't mean to suggest that these are totally separate answers. You might be some combination of both of these, but I think we can make some interesting progress on understanding physics as an enterprise if we try to pursue this second answer here, and that's what I'm going to do. So, if we're going to pursue that second answer, we're going to have to ask another question, which is, what are the laws useful for, right? If we're saying that we're interested in the laws because they are useful to us, well, what are they useful to us in doing? What do they help us do? And the natural way to answer that question is to look at the various roles that laws of nature play in physical practice, right? So one of the things they do quite readily and quite often, or physicists do with them quite readily and quite often, is explain natural phenomena, right? So if you want to know why, for example, the planets orbit the sun in ellipses, you can appeal to Newton's laws of motion and the law of universal gravitation and derive the elliptical orbits of the planets from those. So, that is a frequent use, that kind of use of the laws in explaining natural phenomena, I think is quite common. Another use of the laws is in evaluating counterfactuals, right? So a counterfactual is a claim we write about what would have been the case if something had been different. So if the Earth had been moving more slowly, it would have fallen into the sun as opposed to orbited it. That's a counterfactual that, again, you could use Newton's laws of motion to evaluate and show that it's true. So both of those uses of the laws are common in physical practice. And I think they're, to various extents in different contexts, quite useful. But I think a more straightforwardly practical use of the laws, which is not necessarily independent from these other two, is just their use in making predictions, right? So we can use the laws to make predictions about all sorts of different phenomena, whether it's the trajectories of planets or spacecraft, or the temperature in the core of a nuclear reactor, or just the path of a baseball if it's pitched at a certain speed and angle relative to the horizon, right? In all these different contexts, we can use the laws to make predictions about what's going to happen. That's actually, when you think about it, kind of a remarkable fact, right? The laws are useful for making predictions about all these different kinds of phenomena. So I think my central question then for this talk is going to be about that point. Why is it that the laws of nature are so predictively useful? I think that by lingering on that question, first trying to figure out exactly what it is that makes them so predictively useful, and then trying to understand how that informs our understanding of the laws themselves, we can get some insight into debates about the metaphysics of laws, and in particular about humanism or non-humanism, which is the right way to think of the laws. Which is nice to me because that's one of the debates that I spend a lot of my time thinking about. But it also, I think, is going to give us some insight into this enterprise of physics as a whole. Again, what it's aiming to do. So I'll stop gesturing at that cryptically and actually try to make good on it now. So here's the outline for the talk. I just gave you the introduction. Section 2, which we're about to get to, is about explicating this idea that the laws of nature are predictively useful. When I say that, can we develop that idea any more to show what it is about them that makes them predictively useful? So to do that, I'm going to use this analogy, a maze analogy, which you'll probably be sick of in a few minutes. But that's how I'll try to explicate the predictive utility of the laws. And by the way, I'm sorry if you can hear my dog snoring in the background. She does not care that she's very loud. So that's what's going on if you can hear her. In section 3, then, I'm going to give a kind of, I'll call it a selectionist explanation for the predictive utility of the laws of nature. That is, explaining why the laws are so predictively useful in a kind of selectionist manner. And I think it's a manner that only works if you have a Humean conception of what laws are, only on a Humean metaphysics, where laws are certain sorts of patterns in the events comprising the entire space-time manifold. And then in section 4, I'll contrast that. I'll give another kind of explanation. I'll call it an anthropic explanation of the predictive utility of the laws of nature, which I think is friendlier to a non-Humean view of what laws are. But I also think it's maybe less compelling than the Humean, the selectionist explanation is. And so I'll present a worry about that explanation as well. And then I'll conclude in section 5 by trying to draw those grand conclusions about the physical enterprise as a whole. So that's the agenda here. Okay, so section 2 now is about trying to explicate this idea that the laws of nature are predictively useful. And I said I was going to use this maze analogy, so here's a maze. Let's start with a philosopher's favorite thing, a thought experiment. Suppose you're navigating a big hedge maze like this, and it's fun for a little while, but eventually it's not so fun anymore, right? Maybe it's getting late, you're getting cold, you're getting hungry. You would like to find the exit. So you're not making much progress. Eventually you come around, you turn a corner, and there is a mysterious stranger there who offers to sell you a package of information about the maze to help you escape. And let's say they have 5 packages in total, 5 different packages of information about this maze. but you only have enough money to buy one. So what I want to do is consider what the best option is going to be. So I'm going to run through the different packages of information they're going to offer you in just a second here, and think about like what would be the benefits or detriments of that particular package, and try to find what the best one is. So the first package they offer you, package number 1, is just information about the total number of lefts and rights you're going to have to take to escape from your current position. Right. So the idea is that given where you are right now in the maze, they're going to say, well, given that you're here, you have to go, left a total of 34 times and right a total of 32 times, and then you'll be out. They don't tell you the order, but they do tell you in total you have to go this many lefts and this many rights to escape. If that's what they offered you, I think you would be not too impressed, right? I mean, maybe that's sort of academically interesting information that would be useful to some, or would be interesting to someone that wasn't embedded in the maze trying to escape it. But since you are embedded in the maze trying to escape it, this information is not going to be that helpful, right? It's not going to really tell you what to do at any point in particular, unless, it's the odd case where it's just go left 14 times and then you're out, or just go right 24 times and then you're out. But if there's any combination of lefts and rights, then suddenly it's far less useful to you. So one way of putting the problem with package number 1 is saying that it's not dynamically informative, right? It doesn't tell you what to do based on your current, your current position. Good. The second package of information that this mysterious stranger is offering you are directions that tell you where to turn based on facts about the opposite side of the maze. So the idea here is that these are going to be sort of conditional instructions. They say, if the opposite side of the maze from your current location has such and such a configuration, then you ought to go left. And if it has this other configuration, you ought to go right, and so on and so forth. Right? So in some sense, those directions have a feature that's better than the first instructions, the package number 1, right? Because they do depend on your current location, right? They depend on really what the maze is like on the opposite side of your current location. But that's a way of depending on your current location. So they are, in some sense, dynamically informative. The problem here is that they're not spatially local, right? They don't tell you what to do based on information that you have access to. They tell you what to do based on information that you don't have access to. What's going on the other side of the maze? What's the configuration over there? Probably you don't know those facts, right? As an agent embedded in this maze. So while it's in some sense more helpful than package number 1, in some sense it's no more helpful at all because it relies on information that you don't have access to. Okay, so far this mysterious stranger is not being too helpful. Let's look at package number 3 here. Package number 3 is kind of similar to package number 2. These are a set of directions that tell you where to turn based on your position with respect to the maze's center. So again, these are going to be kind of a set of conditional instructions. They say things like, if you are so and so far from the center of the maze and you are located, I don't know, southeast of the center, then you ought to go left. If you are this far from the center of the maze, maybe closer to it, and you're due east of the center, you ought to go right, and so on. I think the conclusion here is similar to the conclusion about package number 2. In some way, these are kind of responsive to your current situation, your current location in the maze, but they're again relying on information that as an agent embedded in this maze, you're not likely to have access to. Right? So a way of putting the point here is that they're not spatially and rotationally symmetric. Right? They require you to be able to locate and orient yourself within the maze in order to make use of them. And again, as an agent embedded in the maze, it's not obvious, or probably not the case, that you're going to be able to do that. Okay, so Mysterious Stranger is so far letting us down with the information they're offering to sell us. Let's look at package number 4. Package number 4 is just complete directions about how to escape from your current position. That's pretty good, right? You know, if you were offered that, you might think, I got to buy that one. But since it's package number 4 and not package number 5, maybe you can guess that I'm going to suggest that it's not the best you could hope for. It's pretty good though, right? If you were given this package, the option to buy this package, this would do it. Like, this would work, right? It would say, you know, first go left, then go right, then go right, then go left. And if you follow these directions exactly, you'll be out by the end of it. The problem here is, imagine these are, you know, pretty long, maybe they're like 54 steps or something. And, you know, you're on step 38 and you're looking back at what you just did and you're thinking, you know, on step 35, it said I was supposed to go left, but I kind of think I went right. Now what do I do? Right? So if that is where you find yourself, you know, if you stray at all from these directions, or if you think that you've strayed at all, or you're not sure whether you've strayed at all from the exact directions that these give you, then suddenly these directions become a lot less useful, right? Now, a way of putting the problem here is that they're not widely applicable. They apply only given your precise starting location and only insofar as you don't deviate from the path that they tell you. But if you do deviate, or if you had started anywhere else in the maze, then they wouldn't have worked anymore, right? So they won't work for your friend who's, you know, lost on the other side of the maze, right? So they're not widely applicable. Okay, that's package number 4. Again, that would work. It's better certainly than the first 3 packages, but it's not as good as you could hope for. What's as good as you could hope for? Well, that's package number 5. That's directions that tell you where to turn based on your current location, right? So they say things, again, they're a set of sort of conditional instructions. They say, if your current surroundings look like this, you should turn left. If they look like that, you should turn right, and so on. Right? So they say, based on the configuration of the maze and your immediate surroundings, here's what you should do. These are directions that are widely applicable. No matter where you find yourself in the maze, even if you take a wrong step at some point, they're going to be sort of self-correcting, right? You'll be able to use these to get out. So my suggestion would be you buy that one. Okay, so those were the 5 potential packages that the stranger offers to sell you. The best of those, I think, is package number 5. So let's summarize the results of this odd investigation that seems like it has nothing at all to do with the laws of nature. The collection of features that were useful, that the first 4 packages lacked, I'm going to call those the predictive desiderata. These are, again, dynamical informativeness. You want them to be informative about what steps to take at which points. You want them to be widely applicable, no matter where you are in the maze, no matter if you take a wrong step at some point. You want them to be spatially and temporally local. You want them to depend, the instructions to depend on information about your immediate environment, not about your, you know, the other side of the maze, for example. And you want them to be spatially, temporally, and rotationally symmetric, right? You want them to be, you don't want to have to locate and orient yourself within the maze in order to make use of them. So I'm calling those the predictive desiderata, because those are desiderata features that make a set of information useful for predictive or navigational purposes in a, as it were, in a foreign environment. So a set of information, in other words, is going to be more useful for predictive or navigational purposes to the extent that it exhibits these features. Again, I haven't said anything explicitly about the laws of nature in this analogy yet, but maybe you can see where this is going. The punchline is that almost all of the putative actual laws of nature, or at least the hypotheses about the laws of nature that physicists have taken seriously since the time of Newton, exhibit just these kinds of features, right? So the typical form of a set of a law hypothesis, a hypothesis about what the laws are, is that they're going to be dynamics on an expansive state space, right? So a state space is just like, you know, all the possible states a physical system could be in.
Chris?
And the laws are going to yes.
Wait one sec. Somehow we lost you for a minute or two there.
Oh,
And so
okay.
We missed something. So could you just go backwards just a little bit?
Yeah. How were we on a different slide when you lost me?
Yeah, we were at package 5.
Package 5. Okay. Did I tell you that package 5 was good?
Yes.
Yes.
Yes. Okay. Package 5 is great.
Thank you.
So by package 5 was the upshot there. So what I was suggesting then is that, let me know if I cut out again. I apologize about that. So I was suggesting was that from that list of features that sort of the first 4 packages lacked and package 5 had, we can extract this set of predictive desiderata. Again, these are features that it would be useful for a set of navigational or predictive principles to have. And that's just the 4 features essentially that the first 4 packages were lacking. Right? So we want them to be dynamically informative. We want them to be widely applicable. We want them to be spatially and temporally local. We want them to have these various symmetries. And the point of these, again, is that if they're dynamically informative, then they're going to tell you what to do no matter where you are. That's dynamically informative and widely applicable, really. And then if they're local in these senses and symmetric in these senses, you're going to be able to, they're not going to rely on information that you don't have access to as an agent embedded in the maze. So these are, again, features that would be useful for a set of information to have if you're trying to use it to navigate or predict how to navigate a foreign environment. Right? So that's why I'm calling them the predictive desiderata. And the punchline, which maybe now we're getting back to where we were when I realized that you were not listening, is that the actual laws of nature, or at least most of the putative actual laws of nature that have been taken seriously since the time of Newton, exhibit these features to considerable degrees. Right? That is, the standard form of a theory about the laws is the dynamics on an expansive state space, right? So a state space would just be something that says, like, here are all the possible states that a physical system could occupy. And to have a dynamics on that state space means to say, if it starts in this state, then it will move to that state next, and that state next, and that state next, and so on. If it starts in this other state, it will move to that state next, and that state next, and that state next. So no matter what state it starts in, you can predict how it's going to move or move around through state space over time. So immediately that feature there gives you the first 2 features of the predictive desiderata, right? It gives you dynamical informativeness and wide applicability. Most of the candidate laws we have taken seriously since the time of Newton have been spatiotemporally local. That is, what happens at a given point in space and time depends mostly on just what happens nearby that point in space and time. It doesn't depend on what's happening really remotely in space and time. Similarly, they have been, for the most part, spatially, temporally, and rotationally symmetric. So the punchline, right, is that the actual laws of nature exhibit these predictive desiderata to considerable degrees, or at least all of our best theories about the actual laws of nature do. And that's, I think, a pretty remarkable correspondence, a pretty remarkable correlation. And it's one that I think we should be thinking about, right? Trying to explain, perhaps. So much so that I'm suggesting we impose this kind of no accident requirement, what I'm calling a no accident requirement, which just says that any tenable philosophical understanding of laws of nature ought to be able to offer some explanation about why the laws are so predictively useful, why they exhibit these predictive desiderata to such considerable degrees. And note that if we did have an explanation of that, if we had an explanation of the predictive utility of the laws, why they exhibit these predictive desiderata to such considerable degrees, then we would also have an explanation of why it's one of the central goals of physics to discover the laws, right? It's, look, the laws are really predictively useful, so why wouldn't we want to discover them? Right? So that's the kind of explanation I'm going to be suggesting here in the next section, actually, which I will turn to now. So that's the selectionist explanation which again I think is going to be only available if you have a Humean conception of law. Only available if you think that the laws are really patterns in the phenomena, right? Patterns in the space-time manifold. So here's the space-time manifold, right? It's all, well, not to scale, right? But all the events throughout all of space and time in the entire history of the universe. Each dot here just being some event. An event in this sense doesn't have to be anything, nothing really has to be happening there. It could just be an empty point in outer space somewhere. But there are all these events throughout all of space and time. And the first thing to note here, to see how this explanation is going to work, is that there is a kind of plurality of patterns in the space-time manifold among these events, right? A pattern would just be, again, remember the Humean things, laws are patterns, right? Well, what's a pattern in this setting? A pattern is essentially just a way of connecting some or all of these dots, right? That represent the individual events. So some of these are going to be more natural than others, right? So there's a pattern connecting some of the dots in the space-time manifold. Not a very natural-looking pattern, but it is a pattern nonetheless. There are other ones too, right? So there's a pattern that sort of goes around the outside, as it were. I don't know exactly what the outside is here, because remember, this is supposed to be all the events throughout all of space and time. So don't think of this as just the edge of the universe. But regardless, this is a schematic drawing. Plenty more patterns we could draw here, right? So there's another pattern. That one tries to hit a bunch of the events in the middle. Here's a disconnected pattern, the yellow one. It's got a piece over here on the left, a piece up here in the middle, and a piece over here on the right. And you get the point, right? You could draw tons and tons and tons of these patterns to your heart's content. And so that's the immediate point, right? Just that there are, given the space-time manifold, given all the events throughout all space and time, there are a wide variety of different patterns you could use to connect those events. Good. Okay. So the challenge for the Humean is going to be, the Humean wants to say, right, that the laws are certain sorts of patterns in this space-time manifold. You want to find some way then of distinguishing the patterns that constitute laws of nature from the patterns that don't, right? Because if there are so many patterns, well, lots of things that happen in space and time are not laws of nature. Only some of them are. So what makes the difference between the ones that are and the ones that aren't? A natural first thought would be that the patterns that constitute laws are the ones that are universal, the ones that hold throughout all of space and time. So that's what I'll call the naive Humean view. That is, every universal pattern is a law of nature. That's not going to work. And the reason it's not going to work is that there are many universal patterns that are not laws of nature. Right? So the philosopher Hans Reichenbach had the example that all gold cubes have a volume less than 1 cubic mile. Arguably, that is true, right? Throughout all of space and time, all of the gold cubes there ever are or ever will be have a volume less than 1 cubic mile. Nevertheless, it's not a law of nature, right? If an exceptionally rich person had wanted to make a gold cube with a volume greater than 1 cubic mile, then, they might have done it, right? In fact, there are other things that they actually do try to do that are almost equally stupid. So it wouldn't be that unreasonable for that to happen. But it is probably true that there are, throughout all space and time, no gold cubes that are that have a volume greater than 1 cubic mile. But that's definitely, again, not a law of nature. Another example here was due to the philosopher David Armstrong. He says, look, all centaurs are excellent philosophers. Well, there are no centaurs, let's suppose. So that pattern is sort of trivially true, right? Any centaurs there are excellent philosophers. That's a pattern that holds throughout all of space and time, but certainly it's not a law of nature. Right? So this naive human view that the laws are just the universal patterns is not going to work, because again, plenty of universal patterns are not laws. So again, the challenge for the Humean now is to propose better workable standards that distinguish the patterns that are laws from the patterns that are not laws. And I would add, they want to do this in a way that respects the no accident requirement. That is, that makes it, to be expected that the laws are as predictively useful as they are, that they exhibit the predictive desiderata to the extent that they do. Okay. So, by now, the sort of canonical way of distinguishing the patterns that are laws from the patterns that are not laws for the Humeans is to adopt this best system account, which is an account of laws that was developed by David Lewis, the sort of founding father of the Humeans, as it were, aside from David Hume, I guess. So Lewis's idea was that the laws are going to be particular kinds of patterns, those that exhibit a significant degree of two features, simplicity and strength. Right? So simplicity, fairly straightforward. You want the laws to be relatively simple patterns throughout the entire space-time manifold. But you also want them to be strong, that is, informative about what happens in the space-time manifold. So his idea is essentially that the laws collectively, taken as a system, are going to be very simple and yet very informative about what happens in the space-time manifold. A way of thinking about this is that if you knew nothing else about the universe but the laws, you would have a kind of efficient summary of everything that happens in the entire history of the universe. A lot of contemporary Humeans have followed David Lewis in adopting this best system account. But in principle, they don't have to. And in fact, I don't think they should. The reason I don't think they should is because if you adopt this best system account, you're going to run afoul of the no accident requirement. Right? If you think, as David Lewis did, that the laws are essentially an efficient summary of everything that happens in the universe, then it's going to end up being actually kind of mysterious why they exhibit the predictive desiderata to considerable degrees. Right. So think about back to the maze analogy. If you ask for an efficient summary of your escape path, maybe, you might get something like package number 1, right? The total number of lefts and rights that you have to take to escape. That might be an efficient summary from a sort of God's eye perspective about your escape path. But it's not kind of information that's going to be useful to you as an agent embedded in the maze trying to escape. Right? It's not going to exhibit those predictive desiderata. So I think the better way to go is not to adopt Lewis's best system account, that is, Lewis's method for distinguishing the patterns that are laws from the patterns that are not laws, but rather to do what I suggest we do, naturally. So again, the problem with that is that it runs afoul of the no accident requirement. My suggestion is that all we need to do is make the standards for distinguishing the patterns that are laws from the patterns that are not laws the predictive desiderata that we already talked about. Right? So this gives us what I'll call the best predictive system account. That is, we're going to take the entire space-time manifold and we're going to try to systematize it in a way that gives us the best predictive system, that is the system, the patterns that are most predictively useful to creatures like us. The ones that exhibit the predictive desiderata to the highest degree. And those patterns are going to be the laws of nature. So that's what I've called the best predictive system account. It's what I've built a lot of my research around, trying to develop and develop this account and see what work it can do for us. And I think that view is fairly clearly going to respect the no accident requirement. It's going to make it not an accident that the laws of nature are so predictively useful, right? It's because we've selected them for their predictive utility from amongst all the patterns. So here's a way of visualizing that pictorially. Let's go back to our dense plurality of patterns here in the space-time manifold. What the best system account is telling us to do is to select the patterns that exhibit the predictive desiderata to the highest degree, right? So we'll sort of gradually weed out the patterns. I'm weeding out some patterns here, although you can't tell because I drew so many patterns on top of these dots. But we'll gradually weed out the patterns that don't exhibit those predictive desiderata very effectively. And if you keep doing this, eventually what you're going to be left with are patterns that exhibit just the features that you're looking for, right? So it's just the things that you most want to find. Given the dense plurality of patterns, you're likely to be able to find ones that, exhibit those features to a pretty appreciable degree. Good. So I think the analogy here might be to thinking about the constellations, right? You might think like, isn't it remarkable that we can find like human shapes in the stars, or the shapes of teapots or flying horses or swans in the stars? And the thought is no, right? You can connect those dots however you want to, and we connected them in ways that were useful to us, right? So the laws here might be thought of as analogous to, at least in this abstract sense, analogous to the constellations. Okay. So I want to claim that this kind of selectionist explanation for the predictive utility of the laws of nature requires a Humean understanding of the laws, that requires us to think of the laws as patterns. Why is that? Well, the selectionist explanation really requires two things. It requires first the selection criteria, the things that we're saying, the predictive desiderata in this case. But it also requires a plurality of similar sorts of entities that you can apply those selection criteria to. Now, of course, the Humean thinks that the laws are just patterns in the space-time manifold. And as we just saw, there are a plurality of patterns in the space-time manifold. There are a plurality of ways of connecting those dots. But the non-Humean doesn't think that, right? The non-Humean thinks the laws are sort of metaphysically unique, right? They're something that stands behind, as it were, the space-time manifold and governs or controls it, right? And on that view, you don't have a plurality of similar sorts of entities that you could apply these selection criteria to. You just have these unique things that stand behind the mosaic, the space-time manifold, and produce it. I said mosaic there because David Lewis has this phrase, the Humean mosaic, which is just what he calls the space-time manifold, right? Because it's a bunch of different events arranged in space and time. Artistically, maybe it looks like a mosaic or something. But anyway, good. So the point was supposed to be, right, this works on non-Humeanism, or it works on Humeanism. It does not work on non-Humeanism. And it's a cool explanation, I think, right? It's an explanation that, like, it would be nice. It would be a cool way to think about why the laws are useful if that were the right way to explain it. Okay, do I have time? I can talk now about an alternative explanation that might work better on a non-Humean view of laws. Is this something that I'm also happy to stop now if I've gone on for too long? So let me know.
Good, Chris. Keep going.
Okay, great. So I'll say a bit about this explanation and then also try to say a bit about a worry about it, because I don't think it's as compelling, though I also am maybe biased because I already think Humeanism is probably right. Okay, so the idea here is we're going to rely on the notion of an observational selection effect. Right? So a selection of, again, the task is explain why the laws are predictably useful, but do so in a way that makes sense on a non-Humean view of laws, a view where the laws are some sort of entities producing or governing or constraining the space-time manifold of events. So again, we're going to rely on this notion of an observational selection effect. A selection effect in general is just where you're gathering data and your sample is biased by the data collection process, right? So a standard case would be that I'm fishing with a net and I'm wondering why I'm not getting any small fish. And you point out, well, Chris, you have giant holes in your net, so the small fish are just going to leak out, right? So that's my sample of fish that I'm gathering are going to be biased because of the selection method. An observational selection effect is just one where the data is biased because it's the kind of data that has to be the kind of data that's observable by agents, or that's likely to be observed by agents. So some examples of this, at least alleged examples of this, might be the fine-tuning of the cosmological constants, right? So if you look at some of our best physical theories, they have these real number valued constants that if they took slightly different values, it looks like there would be no possibility of life in the universe. And one suggested explanation of that fact is that, well, we can only find ourselves in universes with constants that permit life, right? So it's maybe not so surprising that ours do. Whether that works or not is an open question, but that is one of the responses to that observation. Maybe a little bit more down to earth case is the slowest lane phenomenon, and when you're stuck in traffic, right? So you're stuck in traffic, and I don't know if you all have this experience. Probably, if this is right, you do. I certainly do. It always feels like I'm in the slowest lane, right? It feels like more often than not, at least, I'm in the slowest lane. And even when I change lanes, now the lane I change to is the slowest lane. Why is that? Well, if you think about it, right, what is it that makes a lane the slowest lane? It's got the highest density of cars in it, right? And so you're probably, anyone randomly sampled is most likely to find themselves in the lane with the most cars in it. If you're stuck in traffic, you're going to be more likely to find yourself in the lane with more cars in it than the lane with less cars. So that's a potential explanation of this phenomenon here, that it always feels like you're in the slowest lane. And so we're going to try to use a similar explanation here for the predictive utility of the laws of nature. That is, we're going to try to suggest that maybe we should only expect to find ourselves in universes where the laws are predictively useful to us. Why is that, though? So that's the general idea of how are we going to make good on that? Essentially, we're going to try to reverse the selectionist explanation that I just gave for the Humean. So rather than us selecting for certain features in the laws, we're going to make the case that maybe the laws have selected for certain features in us. Right? So what's the story here? Well, according to non-Humeanism, the laws are governing, are constraining, are controlling the behaviors of all physical systems in the universe. Well, we ourselves are physical systems in the universe. And so the thought would be, if the laws had been different, maybe our sensory capacities and our epistemic access to the universe would have been correspondingly different, right? So it's like, look, I can see things locally in my environment, locally in space and time. Why is that? Well, it's because the laws themselves are local, right? It's because the laws themselves are such that what happens at point A depends on what's nearby point A in space and time, not what's really remote from point A in space and time. If the laws had been radically non-local, that is, if what happens at point A had depended on what happens at point Z, which is really far away from point A, then maybe likewise our sensory capacities would have been very different as well. Right? Maybe I would have been able to see the other side of the universe or whatever. So this is the general idea. I will grant very quickly here that this is a little bit hand-wavy. Well, everything I've said here is a little bit hand-wavy, but this is a bit more hand-wavy, I think, than even what I've said so far. But that's the general idea, right? That we're trying to explain this remarkable correspondence between the features that would make laws predictive, or a set of principles predictably useful to us, and the features possessed by actual laws of nature. And here we're saying, well, if the laws are in sort of making it the case that certain kinds of things would be predictably useful to us, and certain kinds of things would not, right? So it's clever, I think, but I don't know how well it works. The reason I don't know how well it works is because this is really just, again, going to be a bit hand-wavy, so feel free to ask further questions about this in Q&A. But I think it understates the severity of the underdetermination problem for non-humanism. This is, there's a load of jargon there. But what do I mean? Well, on non-humanism, again, the laws are supposed to govern or produce the entire space-time manifold. And the received wisdom about this in the literature is that this is going to imply that our epistemic access to the laws is pretty highly attenuated if non-humanism is true, right? That is, even if we knew the entire space-time manifold, that would not be enough to know the laws, right? Because the laws are something sort of behind it that are producing it or governing it or controlling it. And so even knowing everything that happens throughout the entire history of the universe wouldn't let us know the laws on this view. Because there's a variety of ways the laws could be such that they produce this space-time manifold. That's the standard, I say, with the received wisdom about non-humanism, that it makes our epistemic access to the laws pretty weak. By calling it the received wisdom, I don't mean to shed any doubt on it. I think it's right. But then I think juxtaposing that with the anthropic explanation I just gives us the sort of worry, right? So that anthropic explanation seems like it ignored this underdetermination problem, right? It kind of suggested that we could infer directly to the nature of the laws just by examining features of ourselves, right? We could figure out, well, look, I see things in my environment local to me, therefore the laws must be local. I can't orient myself in space, therefore the laws must be spatially symmetric, right? That seems like a really surprising amount of access to the laws that we can have without really doing much empirical investigation at all. So I think, and again, this is more just a suggestion that there must be a problem here with the anthropic explanation as opposed to pointing out what the problem is. But the problem looks like, the reason to think there's a problem, again, is just that it is suggesting we have much more epistemic access to the laws without doing almost any empirical investigation than it seems like we actually would if non-humanism were true. Okay. Good. That's the end of section 4. Let me try to conclude now by making good on some of those grandiose claims I gestured at the beginning. So the first sort of take-home point I want to mention is just that we should be trying to explain the predictive utility of the laws of nature, right? The fact that there are these predictive desiderata and that putative actual laws of nature exhibit them to considerable degrees looks like it is something that we ought to be trying to, think about and figure out why it's the case. I also tentatively want to suggest that the selectionist explanation I gave in section 3 is a better explanation than the anthropic explanation of the law's predictive utility. If that's right, and it's also right that the selectionist explanation can only be given on Humeanism, then I think this supports a Humean view of laws over a non-Humean view of laws. You might wonder, a sort of natural follow-up would be to wonder whether there are alternative explanations of the law's predictive utility. And I'm sure one could cook up some. You might try to give a kind of theological explanation of the law's predictive utility. That's not something I've pursued at all, but I could imagine there being alternatives as well, and it would be interesting to think about how they cohere or don't cohere with Humeanism or non-Humeanism, and which they support. Anyway, if all this is right, which that's a big if, here are the grandiose claims now. First, physics should be thought of as a fundamentally humanistic enterprise, right? It's not an investigation into deep hidden structures that have only an inessential connection to our practical concerns, right? Rather, it's an investigation into patterns in the behaviors of physical systems throughout all of space and time, but patterns that are distinguished based on their predictive utility to creatures like us. So physics on this view is an enterprise that makes a lot of sense for humans to engage in for practical reasons. And that's, I think, an interesting way of thinking about it. It's not a way that's sort of common in philosophy of physics right now, but I think it's, there's a plausible case to be made that is the right way to think about it. All right, that's all I've got for you. Thank you.
Thanks so much. We have some questions for you and comments, perhaps in our audience, as well as we're open to anybody on Zoom.
Chris, Chris, that was fantastic. Thank you so much. I have a question, because as I looked at all of that, the emphasis is on the observational nature of that, which is essentially the human element. And I think in cosmology, we know that there's certainly limitations, but then we send out satellites, and we send out telescopes, and we put telescopes on higher mountains with bigger and better ability, and then we try to examine whether the standard model is complete. But it strikes me that one of the things that we need to think about is how we expand that observational science, so it's not that observational portion of your talk. How do we make that so we don't limit it solely to the capabilities of us weak humans in the predictive utility of understanding our systems?
Yeah, cool, right. So maybe here's a way of maybe posing your comment or question in a way that is a little bit more hostile to my point than the way you phrased it, which thank you for not phrasing it too hostile. But if I'm right, why should we be going to such great extents to like put telescopes in outer space, or put them on mountaintops, or invent these new ways of investing? Isn't it good enough just to have, the predictively useful summaries of the stuff that's happening here on Earth, right? Why do we need to look and observe stuff elsewhere? Which is a good question, right? One thought would be, look, there's plenty of phenomena in outer space that also can affect us here on Earth, so we need to be able to make predictions about that as well. And more generally, maybe you can find things by examining distant galaxies that are also useful for making predictions about things here on Earth. Maybe they improve our understanding or predictive leverage over phenomena here on Earth, things that are more immediately relevant to us. So I'll admit that's a hand wavy answer. I do think that if you, and this is, well, anyway, I do think that if you really buy into this idea of physics as its primary goal is predictive utility and finding principles that are predictively useful, or one of its primary goals is doing that, then you have to take seriously the possibility that it's sort of already found the best ones, right? That what we're doing nowadays might not be getting us better predictive leverage, all things considered. Maybe there are like limited domains where we can get better predictive leverage, but in sort of like the big picture, maybe we've already topped out in, I don't know, Newtonian mechanics or quantum mechanics or general relativity, and that the best we're doing now, or all we're doing now, is sort of fine tuning the predictive leverage we have over smaller domains. I think that is if you buy into this view that I've been sort of pushing here, I think that's an open question.
Well, I want you to know that wasn't meant to be hostile at all. It's just, I wonder, how do we make ourselves better observers so that we can understand more, because we need lots of predictive utility.
Yeah, I agree. Right. Maybe I turned it into a hostile question just by thinking, what in the picture I've suggested here motivates why we would need to look outside of our immediate environment. Right? Thank you.
I have a question of, all of a sudden, very early on, you introduced the requirement of rotational symmetry without explaining why that is even a requirement. Oh,
okay, right. So all I was thinking there was, if you're in the maze, you want to, imagine the instructions. I think this was package 3 that you're offered. They tell you which way to turn based on your position with respect to the center of the maze. Right? So that's going to require you to be able to orient yourself within the maze, right? So maybe they say if you do south of the center, go left. If you're northwest of the center, go right, etc. So being able to orient yourself within the maze, and that's something you probably can't do as an agent embedded within it, trying to get out of it. And so that's why it would be useful for them to be for the information that the stranger sells you to be rotationally symmetric, right? To not require you to orient yourself within the maze in order to make use of them. That was the thought there.
Great. Other comments or questions?
Hi, Chris. I I can't follow all the metaphysics. This is Ophelia. We've met over the course of ILR when you lectured before.
I remember that, yeah.
But I am I'm just thinking about the pattern view and whether it's just a selection of patterns of effects where the notion of cause gets lost. So that if what you're looking at patterns of predictive utility, which is, I don't have a problem with that. How are all those patterns interrelated among themselves? And whether it's just a series of effects that kind of correlate together from an observational point of view.
Yeah, good. Yeah, I think I get. So here's a way of putting your point. Let me know if this is not getting it. But if you have this view where laws are just patterns, and really there's the space-time manifold, all these events happening throughout all of space and time, but nothing deep connecting them, right? Right. There's nothing that it's fundamentally it's just the events, and then we're kind of giving you a summary or a description of the events when we find the laws of nature. But then where's the oomph, the causation, right? Where's causation in that picture? So the Humean, the person who thinks of the laws as patterns in this way, is going to try to give, they're already giving a kind of deflationary view of what laws are, right? They're just patterns. They're not something behind the scenes producing stuff. They're likewise going to try to give a kind of deflationary view of what causation is, right? Causation is just certain sorts of correlations between events in the space-time manifold, right? There's no extra oomph or necessity to causation beyond those, certain sorts of strong correlations, basically. I don't know if that answers your question or just sort of acknowledges that it's not the most intuitive understanding of causation, I suppose.
I know the Humean view. I mean, okay. I'm familiar with that. But I was just wondering what you thought from the philosophy of science about, we talk about patterns, and it seems to me that the patterns are a series of effects among themselves, because the predictive utility has to do with effects, with producing an effect that is useful. And so I was just wondering from your point of view, what would be the pattern of the pattern, as it were, the metaphysics of the pattern itself, the essence of the pattern. Because we talk about patterns that have this predictive utility, but we never answered what is a pattern,
Okay. So is it a kind of...
its features interrelated among themselves? But that's a different question. You don't have to answer it today. It was just, I don't know. I thought I was coming from some outer, third planet kind of talk, but this is what I was wondering when you were talking about patterns. That's all.
So I'm not sure I got it, but here's something that you said made me think that this is the issue. Namely, I want to say that patterns with these features are predictably useful. That is, that they produce this effect that we can more easily make predictions when we use these patterns, or when we pick up on these patterns. But what is that notion there, right? What is that? They more easily produce this effect on us, that we have better predictive leverage now. Is that what you're asking about?
Well, what I want you to think about, and we don't have to take up the space now, the time now, but what is the essence of a pattern? Or what is like we just drop the word pattern and say there are all these patterns that are creating these predictive effects. Well, when the observer finds a pattern, because it will depend on the observer to find a pattern, I suppose, because they're not in themselves, as it were. So, so how do you describe, let's say, not even explain, how do you describe the internal coherence within a pattern, let's say? So, but that's just a question to think. That's what I was thinking about. And I don't know if it's an important question or not. It's just what I was thinking about when I heard you speak.
I definitely think it's an important question. If I've got it, I mean, I think I'm not entirely sure I've got it, but I think that there are certainly important questions about, for example, whether patterns are just sort of observer relative, like I think you might have hinted at in your point just now, or whether they're objectively, and just different observers will see different ones. I think that's a really interesting question. I think, is there such a thing as an unobservable pattern? Would be a question, maybe in the vicinity at least, that I ought to think about here. This is reminding me of a classic paper by Daniel Dennett called "Real Patterns," where he gets into these kinds of questions. Maybe I should go back and take a look at that. But thank you.
I guess my thought was, or my question sort of was, sure. Einstein had that unifying theory that he was trying to bring all these, his relativity and quantum and all that stuff together. So it sounds like what you're saying is everything's so random that his quest was futile in the end, because there really is no underlying rule. It's just random patterns, and there's no way that all those random patterns are going to come together. Is that what you're saying?
No, but I can see why it looks like I'm saying that. What I was trying to say was that if there is a theory that unifies, say, general relativity and quantum mechanics, what that theory would be is just a more predictably useful pattern amongst the entire space-time manifold, right? So maybe the way to think about our current predicament is that we've got general relativity, which is great for making predictions about macro scale patterns, and we've got quantum mechanics, which is much better for making predictions about micro scale patterns, and they don't fit together, right? So, but if there were a unified theory that basically a theory of quantum gravity that put them together, what would that be on this view? It would be a better one that sort of all at once gave us the best predictions about the best predictive leverage over macro scale and micro scale phenomena simultaneously. Does that answer your question?
He said yes.
Okay, great.
All right, any final questions? Well, let's thank Professor Dorst for an amazing presentation. Very, very predictive and useful. So
Thank you so much for having me.